nagbabasa ko pa kami sa
Hello everyone. Our topic for today's discussion is about introduction to data warehouse. Listed here are some key points to be discussed. Basic concept of data warehouse, modeling, design, usage, and implementation. So, what is data warehouse? A data warehouse is a type of data management system that is designed to enable and support business intelligence activities, especially analytics. Data warehouses are solely intended to perform queries and analysis and often contain large amounts of historical data. It is also known as enterprise data warehouse. It's a kind of data management system din na nagko-collect ng mga data from different sources at ini-store ini-store into a single centralized na parang storage ganun. Typical data warehouse often includes the following elements: relational database to store and manage data, an extraction, loading, and transaction solution for preparing the data for analysis, statistical analysis, reporting, and data mining capabilities, client analysis, tools for visualizing and presenting data to business users.
Next is the data warehouse modeling. So what is data warehouse modeling? It is the process of designing the schemas of the detailed and summarized information of the data warehouse. So the goal of data warehouse modeling is to develop a schema describing the reality or at least a part of the fact which the data warehouse is needed to support. So, below, makikita yung data warehouse model. Makikita yung databases, tapos yung optimized warehouse loader, and query and analysis tools. Next. So, next is the structure of data inside the data warehouse. It is composed of current detail record, order detail data, lightly summarized data, highly summarized data, and the metadata. So, the current detail record reflects the most current happenings, which are commonly the most stimulating. It is numerous as it saves at the lowest method of the granularity. It is always saved on disk storage, which is fast to access but expensive and difficult to manage. So, yung current detail daw po, yung pinakaunang happening. Next is the order detail. The order detail data is stored in some form of mass storage and it is infrequently accessed and kept at a level detail consistent with current detail data. So ito na po yung sunod sa current detail. Next is the lightly summarized data. The lightly summarized data is data extract from the low level of detail found at the current detailed level and usually is stored on the disk storage. So siya yung galing dun sa sa current detail. Tapos na-store siya dun sa disk storage. Next is the highly summarized data. It is compact and directly available and can even be found outside the warehouse. Next is the metadata. The metadata is the final element of the data warehouses and is really of various dimensions in which is not the same as file drawn from the operational data, but it is used as directory to help the DSS investigator locate the items of the data warehouse. So magagamit na po ito para i-locate yung mga items sa data warehouse. Then, nasisilbi rin tong guide to map the record of the data as it changed from the operational data to data warehouse environment. And then, nagsiserve din itong guide to the method used for summarization between the current accurate data and the lightly summarized information and the highly summarized data. Next. So, ito naman po yung data modeling life cycle. The data modeling life cycle is a straightforward process of transforming the business requirements to fulfill the goals for storing, maintaining, and accessing the data within IT systems. The result is a logical and physical data model for an enterprise data warehouse. Below po makikita yung data modeling life cycle. Nagsisimula sa business requirements, sinundan ng logical data modeling, physical data modeling, and finally, mapufulfill na yung business requirements for data storage. Next. The conceptual model. Conceptual model recognizes the highest level relationships between different entities. So, makikita yun din sa example. Ayan yung sales pack. Sales pack yung yung highest level. It contains the essential entities and the relationships among them. No attribute is specified. Also, no primary key is specified. Next is logical data model. It defines the information in as much as structure as possible without observing how they will be physically achieved in the database. Ayun po yung example ng logical data model. So, yun sa example nakita natin na ang logical data model ay nag-involves ng entities and relationships among them. All attributes also for each entity are specified. The primary key for each entity is stated. Makikita natin dito sa example. Then, referential integrity is specified. Next is the physical data model. It describes how the model will be presented in the database. A physical database model demonstrates all table structures, column names, data types, constraints, primary key, foreign key, and relationships between tables. So, dito sa physical data model, makikita yung kung paano ipipresent yung database model. So, dito sa example, nakita natin dito yung relationships ng mga attributes. Kasama yung primary key, foreign key. It contains a specification of all tables and columns. Foreign keys are used to recognize relationships between tables. So, kagaya lang ito nung pag gumagawa tayo sa database yung dating pinapagawa sa atin. Next. Next is the types of data warehouse models. Number 1 is enterprise warehouse. So, ang enterprise warehouse collects all the records about subjects spanning the entire organization. Next is data mart. It includes a subset of corporate-wide data that is of value to a specific collection of users. The scope is confined to particular selected subjects. Data marts is divided into two parts, the independent data mart and the dependent data mart. Next is the virtual warehouses, a set of perception over the operating database. For effective query processing only, some of the possible summary vision may be materialized.
Data warehouse design. It is a single data repository where a record from multiple data sources is integrated for online business analytical processing. This implies a data warehouse needs to meet the requirements from all the business stages within the entire organization. So there are two approaches, which is the top-down approach and bottom-up approach. The top-down design approach. Here, a data warehouse is described as a subject-oriented, time-variant, non-volatile, and integrated data repository for the entire enterprise. Data from different sources are validated, reformat, and saved in a normalized database as data warehouse. The data warehouse stores atomic information, the data at the lowest level of granularity, from where dimensional data marts can be built by selecting the data required for specific business subjects or particular departments. Advantages of top-down design. Number 1 data marts are loaded from data warehouses. Developing new data mart from data warehouse is very easy. While the disadvantages of top-down design, this technique is inflexible to changing departmental needs. The cost of implementing the project is high. Bottom-up design approach. So, dito sa data warehouse na to, data warehouse is described as a copy of transaction data, specifically architecture for query and analysis. Term the stars schema. In this approach, a data mart is created first to necessary reporting and analytical capabilities for particular business processes or subjects. Thus, it is needed to be a business-driven approach in contrast to Enmon's data-driven approach. Some advantages of bottom-up design are documents can be generated quickly, the data warehouse can be extended to accommodate new business units. It is just developing new data marts and then integrating with other data marts. Disadvantages of bottom-up design of this approach: the location of the data warehouse and the data marts are reversed in the bottom-up approach design. So here are some differences between these two approach, the top-down design approach and bottom-up design approach. In top-down design approach, it breaks the vast problem into smaller sub-problems, while the other, or the bottom-up design, solves the essential low-level problem and integrates them into a higher one. Next sa top-down is inherently architect, not a reunion of several data marts. Sa bottom-up naman is inherently incremental. Can you schedule essential data marts first? Top-down is single central storage of information about the content. Sa bottom-up naman is departmental information stored. So, top-down is centralized rules and control, while sa kabila is department rules and control. Sa top-down, it includes redundant information. Then sa bottom-up design approach is redundancy can be removed. And the last one sa top-down design, pagkakaiba nila is sa top-down, it may seek quick results if implemented with repetition. At sa bottom-up naman, bottom-up design approach, less risk of failure, favorable return of investment, and proof of techniques.
Ako na?
Oo, ikaw na.
Data warehouse usage and implementation. 1. Requirements analysis and capacity planning. The first process in data warehousing involves defining enterprise needs, defining architectures, carrying out capacity planning, and selecting the hardware and software tools. This step will contain the consulting senior management as well as the different stakeholders. 2. Hardware integration. Once the hardware and software has been selected, they are required to be put by integrating the servers, the storage methods, and the user software tools. Number 3. Modeling. Modeling is a significant stage that involves designing the warehouse schema and views. This may contain using a modeling tool if the data warehouses are sophisticated. Number 4. Physical modeling. For the data warehouse to perform efficiently, physical modeling is needed. This contains designing the physical data warehouse organization, data placement, data partitioning, designing and access techniques, and indexing. Number 5. Sources. The information for the data warehouse is likely to come from several data sources. This step contains identifying and connecting the sources using the gateway, ODBC drives, or another wrapper. Next page. 6. ETL. The data from source system will require to go through ETL phase. The process of designing and implementing the ETL phase may contain defining a suitable ETL tool vendors and the purchasing and implementing the tools. This may contain customize the tool to suit the need of the enterprises. Number 7. Populate the data warehouses. Once the ETL tools have been agreed upon, testing the tools will be needed, perhaps using a staging area. Once everything is working adequately, the ETL tools may be used in populating the warehouses, given the schema and view definition. Number 8. User applications. For the data warehouses to be helpful, there must be an end-user applications. This step contains designing and implementing applications required by the end users. Number 9. Roll out the warehouses and applications. Once the data warehouse has been populated and the end client applications tested, the warehouse system and the operations may be rolled out for the users community to use. Next page. Implementation guidelines. Number 1. Build incrementally. Data warehouses must be built incrementally. Generally, it is recommended that a data marts may be created with one particular project in mind. And once it's implemented, several other sections of enterprise may also want to be implement similar systems. Number 2. Need a champion. A data warehouses project must have a champion who is active to carry out considerable researches into expected price and benefit for the project. Data warehousing projects requires inputs from many units in an enterprise and therefore needs to be driven by someone who is needed for interacting with people in the enterprises and can actively persuade colleagues. Number 3. Senior management support. A data warehouses project must be fully supported by senior management. Number 4. Ensure equality. The only record that has been cleaned and is of a quality that is implicit by the organizations should be loaded in the data warehouses. Number 5. Corporate strategy. A data warehouse project must be suitable for corporate strategies and business goals. The purpose of the project must be defined before the beginning of the projects. Next page. Number 6. Business plan. The financial costs, hardware, software, and peopleware, expected advantage, and project plan for data warehouses project must be clearly outlined and understood by all stakeholders. Without such understanding, rumors about expenditure and benefits can become the only sources of data subversion the projects. Number 7. Data warehouses projects must not overlook data warehouses training requirements. For a data warehouses project to be successful, the customers must be trained to use the warehouses and to understand its capabilities. Number 8. Adaptability. The project should build in flexibility so that changes may be to the data warehouses if and when required. Like any system, a data warehouse will require to change as the needs of an enterprise change. Number 9. Joint management. The project must be handled by both IT and business professionals in the enterprise to ensure that proper communication with stakeholder and which the project is the target for assisting the enterprise's business. The business professional must be involved in the project along with the technical professionals. Next page. Thank you.